What if our first clear chance to photograph an interstellar visitor was deliberately sabotaged? On October 7, 2025, the world held its breath for a portrait of the Interstellar Comet 3 I/Atlas as it flew past Mars. Instead, we got a blurry dot, a global controversy, and a coordinated silence from the world's leading space agencies. This wasn't just a technical glitch, it was the start of a mystery that points to something being hidden in plain sight. Let's delve into it. The blurry dot. It was supposed to be the space photo of the decade, but it looked like a mistake. At precisely 9:22 UTC on October 7, 2025, the European Space Agency released the first official image of 3 I/Atlas, captured by the CASIS camera on the ExoMars Trace Gas Orbiter. The public expected the stunning high-resolution detail we've come to associate with our Martian probes. What they received was a single, fuzzy, underwhelming pixel against the blackness of space. The comet, with an apparent magnitude of +19, was incredibly faint. Within an hour, this blurry dot became a global phenomenon for all the wrong reasons. The team behind the camera, led by its principal investigator, Nicholas Thomas, from the University of Bern, knew they were pushing their instrument to its absolute limits. CASIS was designed to look down at Mars from an altitude of 400 kilometers, not out into the deep void. They had performed a complex slew maneuver, pointing the entire 4,332-kilogram spacecraft at a target 30 million kilometers away that was over 10,000 times fainter than anything the camera was built for. The resulting image wasn't a failure, but a triumph of engineering that required stacking multiple exposures to even get a detection. The world, however, didn't see a technical miracle. It saw a smudge and immediately began asking what was being hidden from view. Global outrage. The internet doesn't wait for explanations, it demands answers. The moment the blurry dot hit social media, the backlash was instantaneous and brutal. Hashtags like fuzzy dot and where are the pics trended in over 20 countries, generating more than 1 million posts on X and Reddit within 24 hours. Side-by-side comparisons showing sharper images from backyard telescopes flooded every platform, fueling a narrative of incompetence, or worse, a deliberate cover-up. Renowned science journalists like Dennis Overby of the New York Times were forced to frame the story not around the science, but around the profound public disappointment. The outrage wasn't just about a low-quality photo, it was about the perceived breach of trust. After being spoiled by the crystal-clear images from the James Webb Space Telescope and the New Horizons Pluto flyby, this blurry dot felt like a step backward, an insult to the €1.7 billion price tag of the ExoMars mission. The simultaneous silence from NASA, China, and the UAE only poured gasoline on the fire. It created a dangerous vacuum of information that was quickly filled with suspicion, turning what should have been a scientific celebration into a full-blown public relations crisis. Technical limits. So, was this a cover-up, or just the hard reality of physics? The truth is, the blurry dot was inevitable, and the numbers prove it. Let me explain. The CASIS camera, developed by a Swiss-led consortium including scientist Gabriele Cremonese, is an imaging powerhouse when pointed at Mars. From its 400-kilometer orbit, it achieves a stunning resolution of 4.5 meters per pixel. But 3 I/Atlas was 30 million kilometers away. At that vast distance, the camera's angular resolution of 11.36 microradians per pixel translates to a pixel scale of about 340 kilometers wide. The comet's nucleus, the solid object at its core, was estimated by astronomers to be only about 15 kilometers across at most. This means the entire comet was just 4.4% of the width of a single pixel on the detector. It's like trying to photograph a single human being standing in San Francisco using a cell phone camera in New York City. No matter how perfect your focus, the light from that object will never fill more than 1 pixel. The fuzzy dot wasn't a blurry image of the comet, it was the entire image of the comet. Its faint light smeared across one single sensor element. It was a technical ceiling, not a conspiracy. The camera could only give a fingerprint, not a portrait. High-rise goes dark. If Europe's camera wasn't up to the task, surely America's best would deliver. All eyes turned to NASA's Mars Reconnaissance Orbiter and its legendary high-rise camera. This is the instrument that can resolve features as small as 30 centimeters on the Martian surface from its 255-kilometer orbit. Its power is, honestly, unparalleled. The team lead for HiRISE, planetary geologist Alfred McEwen of the University of Arizona, had plans to capture what would have been the most detailed image of an interstellar object in history. With its angular resolution of 1 microradian, HiRISE could have achieved a pixel scale of 30 kilometers at the comet's distance, good enough to put several pixels across the nucleus and reveal its shape. But just as 3I Atlas made its closest approach, HiRISE went dark. The official reason given was a US government shutdown that had begun on October 1, 2025, freezing all non-essential operations as part of the fiscal year 2026 budget impasse. Command uplinks to the orbiter were halted, data downloads were stopped. HiRISE team member Candace Hansen-Koharchek confirmed over 300 planned observations were lost, including the critical 3I Atlas sequence. While plausible, the timing felt incredibly convenient to a public prime for suspicion. The crown jewel of Martian imaging was sidelined at the most critical moment imaginable.
Radio silence.
NASA's silence was deafening, but they weren't the only ones who went quiet. 2 other powerful orbiters were perfectly positioned to observe 3I Atlas, China's Tianwen-1 and the United Arab Emirates HOPE mission. Both had been tracking the comet on its approach. Tianwen-1 carries a high-resolution camera capable of imaging Mars at a resolution of 0.5 meters. The HOPE orbiter, managed by project director Omran Sharaf, has the Emirates Exploration Imager, or XI, a multi-band camera that could have provided crucial color data on the comet's coma. Yet in the days following the ESA image release, neither the CNSA nor the UAESA published a single frame of data. No press releases, no technical updates, not even a statement confirming they had attempted an observation. This coordinated silence from 3 independent space powers was, for many, the most damning piece of evidence. Experts in international space policy, like Professor Svetla Ben-Itzhak, have noted that while agencies often keep data proprietary, such a complete information blackout on a major public interest event is highly unusual. Why would 3 nations, often competitors in space, all simultaneously withhold their data? The lack of information felt less like a coincidence and more like an unspoken agreement.
The image wars.
When the professionals go quiet, the amateurs get loud. In the vacuum left by the silent space agencies, a global network of amateur astrophotographers began releasing their own images of 3I Atlas. These images, often the result of stacking dozens of 300-second exposures from 14-inch telescopes, appeared to show far more detail than the official ESA photo. Some claimed to see a distinct star-like core, a faint green tail, and even jets of gas erupting from the nucleus. The internet split into 2 camps. One side, championed by skilled imagers who produce work rivaling professional observatories, like Damian Peach, argued that citizen science was outperforming billion-dollar missions. The other side, composed of professional astronomers like David Jewett, warned that these details were likely illusions, or artifacts. They explained that techniques like aggressive sharpening and AI upscaling, which claim to boost resolution by 400%, can't create new information. They amplify digital noise and can turn random pixel fluctuations into false structures. The debate became a crash course in image processing, with terms like point spread function and signal-to-noise ratio trending on astronomy forums. Without official data as a baseline, the line between discovery and delusion had become, well, hopelessly blurred.
Perseverance streak.
While the world looked to the orbiters, the most intriguing clue may have come from the Martian surface. At the Jet Propulsion Laboratory, Justin Mackey, the imaging scientist for the Perseverance rover, authorized a unique observation. The rover's navigation camera, or NavCam, was pointed toward the constellation Ophiuchus for 10 minutes, taking a sequence of exposures as 3I Atlas was predicted to pass overhead. The raw frames revealed a single faint streak, just over a pixel wide, cutting diagonally across the image. The math was tantalizing. At its known speed of 90 kilometers per second, the comet would have traveled exactly 54,000 kilometers during that 10-minute window. A distance that perfectly matched the streak's angular length if it was the result of motion blur. It seemed like confirmation. But rover operations lead Vandy Verma later noted a catch. The same streak could be produced by a much closer object, Perhaps a 10-centimeter piece of orbital debris from a past mission like Mars Global Surveyor, moving at just 7 kilometers per second over a shorter exposure. Without the full FITS data headers to confirm the exact exposure timing, the streak remained a 54,000-kilometer question mark, the first piece of hard but ambiguous data in a sea of speculation.
Wow signal link.
A blurry dot is one thing. A straight line to the most famous potential alien signal in history is another. As trajectory experts plotted the path of 3I Atlas through our solar system, they uncovered a coincidence that was just too stunning to ignore. The comet's path, when traced back, pointed to a location in the constellation Sagittarius, less than 2 degrees away from where, on August 15, 1977, astronomer Jerry R. Amon detected the legendary WOW signal. A powerful 72-second radio burst at 1420.4056 megahertz that has never been explained. Immediately, online forums lit up with calculations. For an object to produce a signal that's strong from its current distance, it would need a 2.2 gigawatt isotropic transmitter, the equivalent output of a large nuclear power station. The alignment was so perfect, so poetically resonant, that it felt like it had to mean something. Yet, inexplicably, major radio observatories like the SETI Institute, whose iconic scientist Jill Tarter has long advocated for such listening campaigns, announced no coordinated effort to listen for signals from the comet along the hydrogen line, the very frequency of the WOW signal. The silence was no longer just optical, it was now radio silence right when the stakes were highest.
Approaching perihelion.
The mystery is reaching its peak, yet the main character is about to leave the stage. On October 29th, the enigmatic object known as 3I Atlas will reach perihelion, its closest approach to the Sun. It will plunge to a blistering distance of just 0.3 astronomical units, well inside the orbit of Mercury. For the following 38.5 hours, it will be lost in the intense solar glare, a period astronomers refer to as a blackout. This impending information vacuum is allowing every theory, from the mundane to the extraordinary, to flourish. Some astronomers predict the object might completely disintegrate under the intense solar radiation which will heat its surface to over 400 degrees Celsius. But others, including those from Avi Loeb's Galileo project, wonder if this blackout could be used to hide something else, a deliberate maneuver. The Galileo project has put forth a compelling theory, an engineered course correction of even a few dozen meters per second, masked by the sun's gravity, would be definitive proof of an artificial origin. In anticipation of this, the project has announced a plan to use the Allen Telescope Array to listen for any telemetry pings the moment 3I Atlas is expected to re-emerge from behind the sun's limb. The world will have to wait. The approaching blackout is the ultimate cliffhanger in a story already short on answers.
The November tests.
The sun won't hide the truth forever. As 3I Atlas is expected to re-emerge into view in early November, a new phase of the investigation will begin. This will be a checklist of pass-fail tests for the object's authenticity. First, astronomers will work to build a detailed light curve, monitoring its brightness for any surges that could signal fragmentation. Second, its trajectory will be measured with extreme precision by the Minor Planet Center, which will look for any deviation from the predicted path not accounted for by natural outgassing. Meanwhile, another mission is waiting for its chance. The European Space Agency's JUICE spacecraft, currently on its way to Jupiter, is scheduled for an observation window between November 2nd and 25th. Its advanced instruments, including the Janus camera, promise a fresh look from a completely different angle, at a distance of about 0.4 astronomical units. Though JUICE will be farther from the comet than ESA's Mars orbiters were, it will have the advantage of observing 3I Atlas just after its closest approach to the Sun, when it is expected to be in a highly active state. However, due to the vast distances and anticipated low data transmission rates, the full dataset is not expected to reach Earth via ESA's deep space antennas until February 2026. For now, the mystery of 3I Atlas is set to continue. So, what is 3I Atlas? Is it a natural interstellar comet that arrived at the worst possible time, a victim of technical limits and bad timing, or is the blurry dot, the synchronized silence, and the impossible coincidence of the WOW signal pointing to something more profound? The official story tells us of limitations, but the missing data tells a story of its own. We were given a front-row seat to one of the most significant astronomical events in human history, only to have the curtain drawn at the critical moment. The truth remains out there, hidden in the noise of a blurry image and the silence of the world's greatest observatories. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our universe. Until next time, keep looking up InnoVision Tech.